Hello and welcome back to the third part of our topic on Strand 4.1. In the previous two parts, we looked at the chemistry of hydrides and oxides. In this topic, we are going to be looking at the chemistry of chlorides. So let's look at some of the basic properties of chlorides and their general trend. So now let's look at the properties of lithium chloride, which is the first chloride of period 2. Lithium chloride is a white solid at 20 degrees Celsius. And because it is ionic in nature, it is made of a three-dimensional network of positive and negative ions held together. And due to the fact that it has strong ionic bonding, it will result in a high melting and boiling point of lithium chloride. And you can see the melting point. It's very high, which is 605 degrees Celsius. A good conductor of electricity in the molten and solution form because they are free movement of ions. But in the solid form, it cannot conduct electricity because the ions are held in a tight position. Lithium chloride is neutral in nature, neither acidic nor basic. And the reason why it is neutral in nature because it doesn't react with water to produce hydronium or hydroxide ion. Instead, it dissociates in water, breaks down into ions, that is lithium ion and chloride ions. The next kind of chloride in period 2 is beryllium chloride. Okay, a white crystal solid which has a giant ionic structure with ionic bond resulting in high melting and boiling point. Very poor conductor of electricity in the molten state. Okay, well, this is quite unique about an ionic compound. The availability of the ions depend on how much bond has been broken and how readily available the ions are. Now, ionic chloride, even though it is ionic in nature, but it is acidic. Okay, it is not basic. Unlike we looked at ionic oxides, we said that ionic oxides are basic in nature because they react with water to form hydroxides, isn't it? But ionic chloride doesn't have to be basic in nature. And the reason why beryllium chloride is acidic in nature is because it reacts with water to produce an acidic solution, which is hydrogen chloride. A note of the state that the HCl is in. The HCl is in the gaseous state. So that's why I said hydrogen chloride, not hydrochloric acid. Okay. So beryllium chloride with water giving you beryllium hydroxide plus hydrogen chloride. Even though the hydroxide is produced there, it doesn't increase the pH drastically compared to the presence of the hydrogen chloride. So hydrogen chloride lowers the pH of the solution. That is why it is overall classified as acidic. Then we look at boron trichloride, the third chloride in the periodic table. A colorless gas, okay, but in solid form it can also appear to be a gray solid as well. A simple molecular structure with a covalent bond. So this covalent bond is the intramolecular bonding. But because it is a discrete molecule made of non-metals, the intermolecular bonding will be weak van der Waals forces. So that would mean that the melting point and the boiling point will be quite low. It doesn't conduct electricity in either the solid state or the molten state because of the non-availability of the ions or electrons. And it is acidic in nature because of its ability to react with water to produce an acidic solution. So you can see that it produces two very important types of solution. Boric acid, H3BO3 and hydrogen chloride fumes. And now we look at nitrogen trichloride. Okay, so nitrogen trichloride basically is a yellow solid, yellow liquid. It's a yellowish oily liquid as you can see in the picture here. Simple molecular structure with covalent bond, low melting and boiling point due to the intermolecular bonding of weak van der Waals forces of attraction, a non-conductor of electricity, acidic in nature because it reacts with water to form acidic solution, and this is the reason why nitrogen trichloride is acidic. It reacts with water to produce nitrous acid plus hydrogen chloride fume.